All right, let's take a look at the sample test for chapter 2. All right, determine if f of x is a function. Okay, remember we don't want two-timing happening. So let's take a look at our domain. Let's see, we have 4, 5, 6, 7, and 8. Ooh, and 8 happens twice here. Let's see if the 8 is doing any two-timing. Well, 8 is mapped to a 3. 4 is mapped to a 2. So is 5. So is 6, but that's not two-timing. That's just 2 is popular. 7 is mapped to a -1. But 8 is mapped to a 2. So 8 is being mapped to 3 and 2. So because 8 is mapped to 3 and 2, it is not a function. Okay. Now, the following state, if the following is a function, state why you think it is. If it's not a function, explain why not. Well, this is a function. At least I think it is. Because it passes the vertical line test. That means a vertical line cannot hit or intersect with 2 points on the graph. There's no place I can draw a vertical line and hit the graph in 2 places. Okay. 3. Find the domain of the first one. Well, that was just the stuff that's being mapped. And so they're specific numbers, so I can't use interval notation. I just got to list the numbers. So they are, there was a 4, 5, 6, 7, and 8. 4, 5, 6, 7, and 8. And if you try to put interval from 4 to 8, you will get it wrong, because that would include numbers between 4 and 5 and 6 and 7 and 8. So don't fall for my misleading thing here, trying to trick you into put the wrong thing. I have to list the separate ones. Now, the next one here, the domain, I got a square root. Square root says the stuff underneath has to be positive to do the square root. Now, the way you say positive means it has to be larger than 0 or 0. Positive or 0. Just can't be negative. So the way you say can't be negative is it's 0 or bigger. So I say 5x minus 3 has to be greater than or equal to 0. And then I solve this. You got to remember when to flip the sign and when not to. I add 3 to both sides and I get 5x is greater than or equal to 3. Divide by 5, and that's a positive side, so I had 5, so I don't have to flip the sign. And I get x has to be greater than or equal to 3/5. So I can write that in interval notation, which means from interval notation, I can include 3/5 up to infinity, or I can do it with set notation just by adding that, or I can say all reals greater than or equal to 3/5. Write it out in words. Okay, the next one. The only thing that would cause problems is if we have division, and so we have to worry that the denominator is not equal to 0. Well, x squared minus 4 cannot equal 0. So therefore, I can add 4 to both sides if you want. That's the way many of you would do it. Some would factor this. X squared cannot equal 4. So if I take the square root of both sides, I get x cannot equal, do not forget, plus or minus the square root of 4, which is 2. So now how do I write this? Now some people mess up on this test by writing it's going to be all reals except x not equal to plus or minus 2. But it's except plus or minus 2, not except the x's that are not equal, because that would be a double not, and that would mean only 2 and minus 2 should work. So do not put in except x is not equal to those. You say all reals except plus or minus 2, or you say, like this says, the set whose elements are numbers such that the numbers are not equal to plus or minus 2. Or you say in interval notation, from negative infinity up to negative 2, but not including, union, we can use the numbers between negative 2 and 2, but not including those, that's why parentheses, union, the numbers from 2 to infinity. Okay, page 2. Says we got this graph and we're supposed to answer a bunch of questions here. First of all, the domain. Well, it looks like this graph starts at about negative 10, solid dot, so I'm going to say from negative 10 to, and it moves right along until it gets to a half in the x. And a half in the x, there's a hole. So I have to stop the domain at 1/2, open paren so that it doesn't include the half, and then restart it at just past a half, so 1/2 to another hole that looks like at about 2.2, so I'll just write 2.2, don't include it, and then restart it at 2.2 and go on up till looks like it ends at 9 or 9.1 or whatever. I'll just put 9. And that's a solid end. So there's the domain. Now you could have possibly said all the real numbers between negative 10 and 9 except for a half and 2.2. You could have written it out that way too. And you could have done it with set notation. Set notation would have been set whose elements are numbers such that the numbers, let's start. Negative 10 is less than or equal to the numbers which are less than or equal to 9, and x was not equal to 1/2, and x is not equal to 2.2. Not very many nice ways to write this one. The intercepts, that's both x and y intercepts. Intercepts are points, so make sure you make them all be points. And I think we have at least 3. There's one there at negative 8.5 in the x, when y is 0, and negative 1.8, 0. Those are my estimations. And at 5.8 or 5.9 in the y when x is 0. So get the x's and y's in the right places. That's where they cross the axes. Evaluate m of 3. So if I go to 3, it says find the y value at x equal 3. So I don't give a point. It's saying find the y value at 3. So the y value at 3 is about 2.5. That's all I write. I don't say 3 comma 2.5 the point, because that's not the value of m at 3. Now it says the value of m, or the y height, at -6. At -6, the y height looks like it's about -8. So don't make this a point when all it wants is the height. Local maximums. Maximum. High places in their neighborhood. Well, that's a high place, but not in a neighborhood. There's nothing on the left side. The next high place looks like it's here, but there's a hole, so there's none there. And there's a low spot, and there's a high spot, but that's not a local one because it doesn't have neighbors on this side, so there is none. Local minimums. That's a place where water would collect, and the local minimum, there's one here down at -9. You can say at x equal whatever that is, -5, if you want, but you don't have to. The other local minimum is at about 1.8. Happens at 4, but it's about 1.8. So there were 2 of those. Absolute maximum. Well, the very highest place on this graph is right there. It looks like it's about 10 high. Maximum is the height. You can say it's at -10 if you want, at x equal -10, but the height is 10. And then absolute minimum. The very lowest place is -9. Now, if you want to say at x equal -5, you can, but if you get that wrong, I'll take off points. Give the intervals where the function is increasing. Well, if I'm on this roller coaster here, the increasing is when the roller coaster is going up, and that would be from here to there, but you have to do it in terms of x's. So here is about -5, and intervals of increasing and decreasing are open intervals always. So when x is -5, this graph starts going up, stops going up at about 1/2. And then there's another place where it increases, and that appears to be, it starts going up at x equal 4. I know it's a height of 1.8, but you don't talk about the height. You talk about the interval where it starts at 4 and ends at 9. Ends at a height of about 8, but it ends at 9, so it goes up from 4 to 9. Intervals of increasing. Okay, now we have to graph a piecewise defined function. The first piece is defined as y equals 2 plus x. Now I'm going to lightly put some dots in. In fact, I'll do it in red. So if I put in 0, I get 2. If I put in 1, I get 3. If I put in 2, I get 4. And so I've got this, if I put in -2, I get 0. I got this line that's going right this way. And it goes on and on and on forever, if that's all I had to be concerned about. But this graph has a window. It says only do it for x's, not y's. So many people mess up and start it at y equal 1, but it says start it at x equal 1, not including there, so I have an open circle there where when it reaches 1 in the x, and then for 1, x is less than 1, so I draw it this way. Now I have, the second one I have to do is y equal 3x. So I'm going to pull out my red pen again and do, I'll put in 0. 3 times 0 is 0. 3 times 1 is, 3 times 0 is 0. 3 times 1 is 3. 3 times 2 is 6. 3 times 3 is 9. And so it's going like this. That's what it would do. Down 3, down 3. If I didn't have it restricted, but it says here, draw it only between x being 1 and x being 3. So I got to draw that line from 1 to 3, from 1 up to where it reaches 3, which is clear up here. And those are both got equals, so those are closed ends. So that open end that I had from the other one now gets filled in. So I have the two pieces in my piecewise defined function. So now it says list the intercepts. Well, it crosses at 0, 2, and it crosses the x-axis at -2, 0. It says, what is z of -1? Well, -1, I would use this one, so it'll be 2 minus 1, which is 1. Or I can look at the graph at -1, it's at 1. Z of 1. Well, 1 is not in this domain, it's in this other domain, and so I do 3 times 1, which is 3. Or I can look here and see it's 3. And then it says z of 4. Well, 4 is past where this line goes. It's out of this domain, so z of 4 is defined. Now we have to do some algebra with the functions. It says f minus g. F is x squared minus 3x. I'm going to put that in parentheses, then I'm going to write minus, because it says subtract, and g, and I'm going to put in parentheses 2x plus 3. The reason I'm putting parentheses is, if there's a minus, students often forget to distribute the minus. They just want to write this and forget the parentheses, and they miss it. So we got x squared minus 3x minus 2x minus 3, and we get x squared minus 5x minus 3. F times g, that's a solid dot. So we got to do x squared plus minus 3x times 2x plus 3. So we have to FOIL. X squared times 2x is 2x to the third. X squared times 3 is plus 3x squared. Then we got to take minus 3x times 2x, which is minus 6x squared. Then we got to take minus 3x times 3, which is minus 9x. Then we combine like terms, and it looks like these two are like terms, so we get 2x to the third minus 3x squared minus 9x. Now we have to do f of x plus h minus f of x. We spent quite a bit of time doing this. We're not putting f in place of the x in x plus h. We're putting x plus h in place of the x. In f, put x plus h. So f, start off with that. It's x squared minus 3x, but we're replacing the x with x plus h. Minus, notice I'm using these parentheses. Now it's just f of x, so I can actually write it this time. X squared minus 3x, all over h. So now I have to square x plus h. That means x plus h times x plus h. X times x is x squared xh. X times h, h squared. So this is x squared plus 2xh plus h squared. So I have x squared plus 2xh plus h squared minus 3 times this stuff, not just minus 3 times the x, minus 3 times the x and minus 3 times the h. A lot of students miss that minus 3 on the h. And they miss distributing this negative, minus x squared and minus a minus 3x, which is plus 3x. Now, x squareds cancel. The minus 3x and the plus 3x cancel. And I have 2xh plus h squared minus 3h over h. In the numerator, an h factors out. 2x plus an h minus a 3 divided by h. Now the h's cancel, and we get 2x plus h minus 3. D. G divided by f. G is 2x plus 3 divided by h, which is x squared minus 3x, but they said, this does not say times 2. It says put 2 in place of the x's. So I got to put the 2 there, and I should have written parentheses here so I could put a 2 there. So now let's just simplify. 2 times 2 is 4 plus 3 over 2 squared is 4 minus 3 times 2 is 6. So I get 7 over negative 2. All right. In this, we can see that we've got something squared. So the parent function is y equals x squared. So I'm going to put the line down low so that we can have the parabola go up. So there's the x-axis. There's the y-axis. 0, 0, 1, 1, 2, 4. Make sure you get those 5 points clearly marked. Oop. Make the graph go through it. Make it have a nice curve at the bottom. Put some units on your graph so you don't get points taken off. It says units on the graph. Now I'm going to do the inside first. So it says x minus 1. That's on the inside. It's a subtract 1, which means it moves it plus 1. Horizontally. Right 1 unit. So I draw the same axis and I'm going to move it over 1. So now I'm going to have the 4 points are going to be here. And again, I need to remember to put units. And then, now we'll work on the outside. And outside we do it in order of operations. So the multiplication comes before the addition. So I multiply by 2. And outside does exactly what we think it would do. So 2 times as far from the x-axis. So now this point on the x-axis stays there. The point that's 1 above becomes 2 above. And the one that was 4 above becomes 1, 2, 3, 4, 5, 6, 7, 8 above. And so now I have it looking like this, where that's 2 and that's 2. I got my units. And finally, I have to go up 3. So this one, those top 2 are going to be kind of hard to show. And so if you followed it all the way along, I'm not going to be too concerned if you miss it on this one. I missed those top 2, but it's going to be up. Oh, I forgot to say vertical stretch by 2. And this one is up 3. So now this one at 1, 0 goes to 1, 3. At 2 it was 2, so now it becomes 5. And at 0 it was 2, so up 3 becomes 5, and then the other ones are way up there, so we can drop those, but still put units on. And that's what that one. All right, now we have an absolute value. Okay, so the parent is y equals absolute value of x, and I will put that goes up mostly, so I'll put the x-axis kind of low and go through 0, 0, 1, 1, 2, 2, and minus 1, 1, minus 2, 2. There's my parent. Put my units on. And then everything is inside, so everything is working sideways. Everything inside has to go backwards. So you would first multiply by 2 and the minus, and then add 1. So to do the transformations, we have to start at the end, which it says plus 1, so we move it minus 1. So now it's going to be here, 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 there, and there. Where this is 2 and 2. I moved it left 1. And then let's do the minus, which is a reflection over, since it's inside, it's working sideways, so it goes over the y-axis. So now it's at that minus 1, 0 becomes positive 1, 0. The minus 2, 1 becomes positive 2, 1, and vice versa, and so we get it flipped over to the other side. Put my units on, and we call this a reflection over y-axis, or a horizontal reflection. Okay, and then finally, the 2. This is a tricky one for a lot of students. This is horizontally. So we think it would be twice as wide, but since it's inside, it's opposite, so it's half as wide, half as far from the y-axis. Horizontally, we work off the y-axis. So instead of being 1 away, it becomes a half away. If it's right on it, it stays right on it. Instead of being 2 away, it becomes 1 away. Instead of being 3 over, it becomes 1.5 over. Instead of being minus 1/2, it's only minus 1, it's minus a half. And so it looks like that. And put our units on the graph, and we call this a horizontal compression or squeeze by a factor of 2. All right, odd or even? I'm just going to put in 1, see what I get. So 1 cubed minus 2 times 1 is 1 minus 2, which is minus 1. And if I put in minus 1, I get minus 1 cubed minus 2 times minus 1. This becomes minus 1 plus 2, or plus 1. So changing the sign of the x, when that changes the sign of the y, but same number, but changes the sign, that's called an odd. That's symmetric with the origin. 1 minus 1 and minus 1, 1. Symmetric with the origin. Odd. Now let's try 1 in this one. And so if I put in 1, I get 2 times the absolute value of 1 minus 1. 1 minus 1 is 0. Times 2 is 0. Okay, so it's going to be hard to tell if it's odd or even unless it's a completely different number. So now I'm going to put in 2 and put in negative 1. And negative 1 minus 1 is negative 2. Negative 2's absolute value is 2 times 2 is 4. So we got a completely different number, so we learned that it was neither. In this one, I'm going to put in 1. And I get 1 squared minus 2, which is negative 1. Then I'm going to put in negative 1. And negative 1 squared is 1 minus 2 is negative 1. So I got the same number out, so this one is even. Change the sign of the x's, got the same exact number out, makes it even. Final one here. Create a function a of x that gives the area of the rectangle. Well, this point, it says in here, can move on the curve, but it has coordinates x, y. So the area would be width times height, or x times y, because x is how far over, y is how high. But that's not a function of x. So if I want to make this a function of x, then I can have an x in it, but I got to get the y to be a function of x. Well, right here it says that y is 6 minus 0.3x squared. So there is my function. Then it says find the x value that gives the maximum area. So now I'm going to put this in my calculator, what I just wrote, into my y equals, and type in x parentheses 6 minus 0.3x squared, close parenthesis, and graph. Oop, not seeing anything, so I'm going to zoom 6. And negative x's don't make any sense on this one, or could, but I'm looking for over here. So we want the positive x's, and there's looks like there's a maximum here around 2. So I'm going to go second, calculate the maximum, and it's somewhere between 1 and 4. So I'm going to say the left side is 1, enter. Right side of that place is 4, enter. And I'm going to say it's around 2, and it'll tell me find the x value that gives the maximum, and that is 2.58. Approximately 2.58 is the x value that gives that, makes that a maximum area. And that's that test.